This is the second edition of the CUBEC podcast. So for the Canadian Undergraduate Biomedical Engineering Conference. So first I'd like to introduce our guests for today. So on my right, we have Nizar. So if you want to introduce yourself, a little bit about who you are and what you're doing while you're here, I guess. And then Rachel can go along after.
Yeah, Nizar, as you said, my background is in electrical engineering. I studied at McGill. I joined a startup while I was doing research in a small lab at McGill, and that startup continued to exist to this day, became a company, and it's called MY01. I did multiple roles in it, mainly on the electrical and mechanical hardware. Of course, with my background in electrical, I focused on electrical. It's a medical device company, so I did learn a lot about how to take things from a research lab and take them all the way into a product and deploy the product and get all the necessary regulatory approvals and the entire process of taking something from an idea in a research lab all the way to a deployed sellable product.
Very cool. So thanks for being here today. And I guess, Rachel, you can introduce yourself about who you are, besides being my sister. So go ahead.
Hi, I'm Rachel. I also have a background in electrical engineering. I finished McGill 2 weeks ago, so back in December. It was my last semester. In terms of background, I did some research in cancer research, non-invasive cancer detection. I did some research in photonics too, and I also worked at MY01 as an intern for about a year. And now I'm starting a new role in neuronavigation, so that's brain-related things.
Very cool. Thank you for being here as well. So my name is Mark. I'm obviously not as experienced as neither of you. I'm just a student in bioengineering at McGill, and I'm the co-chair of CUBEC for this year. I'd like to talk a bit about our sponsors for the year too. So Medtronic is a title sponsor for CUBEC 24. And I guess we can jump right in to talk a little bit about the industry today, because our first podcast is with the design team on campus, so biodesign, and this is really more talking about student involvement and what kind of work is happening in the biomedical engineering space at an undergraduate level, but you guys being graduates of McGill Engineering, which is pretty cool too. So I guess, Rachel maybe touched a bit about this before, and Nizar as well. I think maybe we can stem into talk about where the interest in biomedical engineering really came from, because you guys both have electrical engineering backgrounds, and usually when I think of electrical engineering, I think of robotics and those kinds of things and circuits, which obviously are involved in biomedical engineering, but where really did this interest in the biomedical engineering field develop for you, Nizar, at least?
So basically, my main interests were related to research. I joined a sensor microsystems lab at McGill. It's actually over there, not far from here.
We're at McGill now. We're at the library.
Yeah.
This is our location for the podcast.
Yeah, it's a sensor microsystems lab, and very soon you realize that in the medical industry, sensors are much needed, and one of the main domains of application for sensor technologies is in the medical industry. So that is one attraction, is that, it's a field of application for what you are working on. The other thing that is related to the interest in the medical device field is that, technically speaking, it offers a very interesting challenge. So if you are an engineer who is looking for a very challenging environment to apply your ideas or to apply your concepts, going into the medical field offers you a lot of space to basically display your problem solving skills. The medical field, by definition, you're operating on people. People look like humans. You do want to make sure they are safe all the time, and you want to apply existing technology to them. So you want to take whatever sensors you have and apply it to them, implant it in them to help them become better, to help them become healthier. So the human body specifically is a very challenging environment to work inside.
for sure.
especially for electronics. It's basically filled with conductive fluids. So I think you've seen it in our work. It's not an easy environment to deploy your technology inside. That's one thing. The other thing is you do have a great responsibility of making sure the person you're deploying your technology into is safe and sound and has a better outcome once it's done.
Wow.
The third thing, which I think comes also makes it easier to be attracted to this field, is sort of the moral or ethical background of this, that the work you're doing is going to help people, is going to help them become healthier, is going to save a father, a son, a mother, a daughter, a partner, and it does make changes in people's lives. So on that, whenever your battery runs out, because work is always demanding and you do run out of energy to do things, once you remember those things, you do have like a better motivation to continue working there.
Yeah, it's very, very good insight.
Yeah.
What about you, Rachel? Can you add on all those three really good points?
Yeah, I think just to reiterate, I guess it's also like the body is by itself also a circuit. So it's in a way, it's cool to always like look at your electronics that you're designing or whatever, and like using the body and like as I guess the medium for it. I guess that was like when I did my research in cancer detection, it was kind of similar because we're working on tumor detection, but we were seeing the tumor as a capacitor that stores energy, and tumors had more water than skin tissue, so that's what you used to actually detect if the tumor was malignant or not. So that was an example. I guess like when I started doing that, kind of brought my interest to the biomedical field, and that was further enhanced, I guess, when I worked at MY01 as well, because there also was diagnostics with electronics in medical field. So
yeah, cool. And I guess kind of Nizar, to what you mentioned before with all the sensors are like in the electrical hardware space, but the application can also be so good in biomedical engineering. That's kind of what you have in MY01, right? Like there's a company like Anixtex who has like the sensor, and you guys are applying it in the medical space too. So the sensor not just applied in the medical space, but this is a good avenue for it.
Yeah, so exactly, it's taking those existing electrical technologies and making them fit for use with the human body. So in the and if you want to develop the sensor for general use, it's not easy, but it's not that challenging. You want to develop a sensor that works for the human body, it's much more. There's a threshold to surpass.
And it's also not only is it more challenging to develop, it's also more challenging to get approval, right? That's probably the biggest challenge there is, because you are dealing with people's lives and people's livelihoods, and I think that comes with not only, like you mentioned, more motivation, more energy, and more desire, but also some more challenges too. So I think that's maybe a good way to talk about like the regulatory additional like workload that comes with working in the biomedical engineering space.
There is a lot of addition that comes into the regulatory work, and I think like it is needed. Basically, those regulations existed for a reason. They did not exist at one point in time. There was no regulation around medical devices you could do, or there was minimal regulation. And then as they see more incidents in the field, they update the regulation and they make it tighter and tighter. Not necessarily tighter, but more considerate of the issues that might happen on the field. The regulatory aspect of medical devices is definitely a big, like having an innovation or having something that works is a good thing, a very good start. But I would say that as you progress a good chunk of say you have an idea and you want to make it into a company, a medical device company, you do have an innovation that you think works well to diagnose or help a certain disease. I would say like that is maybe 10% of the story. Once you want to make this into an existing company, you do, and make it into an actual product that you can sell, at least in North America and Europe, you do have to invest a good chunk of your resources and time as a company on regulations and making sure your device is respecting the regulations. This, you need it, it's forced, but I did touch firsthand that it does improve the quality of your product when you just try to adhere to the regulations. So you come out of the research space with like the research mentality. You have like 5 devices, you do a test on them and you have good results. You write a paper or maybe you write a patent. But in the medical industry, it's not enough to do that. You do have to have, like, first of all, 5 devices. Depending on the risk, 5 devices is typically a small number. Do like 29 and more, depending on the risk. But you do need a very justified sample size in your testing, and it's not the risk that assessing the risk is not sort of like I feel it's gonna fail in this way. There's a very systematic method for people to assess the risk and decide on what testing is needed afterwards. So as the ISO standards, the FDA and Health Canada regulations and European regulations, they do give you a framework to improve the quality of your product. And it's going to take a chunk of your resources as a company or as an inventor. So if you're an inventor who's planning on making your own company, you do need to consider that from the beginning.
Yeah. No, there's definitely lots of challenges on the way. And you said 10% of the work is just the idea itself. But this is not to discourage anybody. It's just it's just to be better prepared. I think. So I guess if we can maybe trace back a bit to like some career pathways. So maybe Rachel, you can talk a bit about why you decided to go into the industry. I know a lot of students, at least in their 3rd, 4th year, start thinking about. I mean, at least I was thinking about it. Like, you don't want to go into grad school, don't want to pursue a master's, don't want to go into industry, don't want to do consulting. I guess there are lots of options as engineers after grad, which is a very good thing. But there is a matter of trying to isolate exactly what you want to go into. So maybe you can talk about your decision to go into industry, because it was a very fresh decision, right? Kind of. So maybe if you talk a little bit about that.
So when I started McGill, I didn't really know. Actually, I wasn't sure if electrical was even my path. I knew I liked electromagnetics when I did classes in CUBEC, and it was interesting, and I knew I liked physics, and I knew I liked math. But then with time, when I learned more about the field, I kind of grew really interested in it. And initially it was through research. So I was like, I'm going to go do a master's, do a PhD, like go into research and teach. And I also like teaching. I did some tutoring and TAing during my undergrad, and I really loved teaching. It was really nice, and I still do. That was always...
You teach me a lot of things too. Help me with my homework. So.
But then I also saw how long it takes. Well, we mentioned that even in industry, it takes a long time to develop things, but in research, you can double it or triple it, I guess. So it's true. Like, because, it's a different approach to develop things. I guess it's less, you're not putting, you're working on stuff very, very slowly, and you're dependent on grants often, and you're dependent on the students that actually join your lab. So sometimes it's a smaller lab and you have 2 students, but one of them wants to work on something else. So it's very dependent on the student as well. So like the lab I worked at the RF breast cancer detection lab with Melissa Popovich in the CSE department. And it was a great experience there. I still work with her sometimes as well. But her research is still, she had 1 clinical trial throughout her whole, through the research. And I liked it too, but I also feel like it's much more fast-paced when you're working in industry, I feel. Like you have a lot more challenges thrown at you at the same time, and I feel like sometimes that makes it more exciting as well. So I think that's how I still might go into research later on, we'll see, but at this point I want to work a few years, see what I really want to work on, and then maybe I'll do a master's, maybe I'll just continue working in industry. We'll see.
Yeah. So you've had multiple research experiences. Like you were also working in PCR.
Yeah, I worked in
for the SURE project. Right?
Yeah, I worked. So I did the SURE project, the SURE program. Highly recommend it to students at McGill.
Yeah, and these just to echo that, there's a lot of programs for students in different universities across Canada to get involved in research in the summer. So like those applications are actually coming up.
Yeah.
So that's something to look out to if you're unsure about, like for myself, like I wasn't sure if I wanted to do research. So I told myself I would do research and see whether I like it or not. It wasn't something that I really saw myself doing like long term, but at least I did it, and I was able to make that conclusion. So yeah, so like you said, you did the SURE project. There's lots of opportunities for that. So if you could talk a bit about your experiences in research.
Yeah. I think, my first research position was when COVID happened. So it was all online. It was my first year. I had no idea what I was doing. It was funny because I spent 2 weeks trying to map some current through a diode, and I didn't know what a diode was. I didn't know how it worked and whatever. So I was mapping it to all the data sheets and everything, and I came up with a formula. And I finished after 2 weeks. I showed my boss like, oh, here's the mapping, whatever. I got an exponential, and then he's like, yeah, that's the formula for diodes.
You already discovered it.
Yeah, I just rediscovered it. Yeah, it was funny, but it was really good to learn on your own, work through challenges on your own, especially when it was online. I didn't have like direct contact with my boss. I met with him once or twice, once a week or once every 2 weeks. So that was a very big challenge. But in research, especially early on when you do it, you really get to explore, I guess. You get to think of ideas and then give your ideas to, like, you can steer your project in different ways. It depends on the lab, but for example, in my second research position, actually I was looking at what they were working on, and I had an idea like, oh, this would be cool if we could also do this. And that actually sprung my whole research to that direction, and we actually submitted a paper on that a few weeks ago. So things like this, it's like you have an idea, you try it out. Sometimes it works, sometimes it doesn't, but sometimes it does work, and it actually ends up helping the research along. So I really love my research experience too. It's really nice.
Very cool. So maybe Nizar, if you can also share about some research experiences that you've had in your undergrad or after as well. I think that'd be interesting for people to learn.
Yeah, the SURE program at McGill is actually a very, very good one. It means summer undergraduate research experience, I guess, for those of you who are not at McGill.
Yeah.
It's a really cool program where you work for 4 months in the summer with a professor. Typically, once you land on a professor and you have a good relationship and you like the research, they tend to rehire you for the next term.
Yeah, I have a few friends who are working in the labs now.
Yeah,
they did a SURE project within their first and second year. So
yeah, and actually for me personally, it determined my career path.
Oh, wow.
So I was, I think, in my second year at McGill, where I went into the SURE program. I joined Professor Vamsey. He's no longer at McGill now. He's in the US. I joined his lab. I did one summer, and there was a project I liked, and he needed some more help throughout the winter. So he hired me as a research assistant in the winter. And then I joined him the summer after. And then while I was doing my summer undergraduate research experience with him in my next summer, other members of our lab founded the Next Sense company.
Oh.
And I was there in front of them, and I remember the current CEO now. His name is Charlie. You've seen him.
Yeah, Charlie.
Yes. He was wearing his shorts in the summer. He's like, we're starting a company. Would you like to join? And I'm like, yeah. So I was employed from that point on. At the beginning, it was like really in line with the research I was working on. But then as it took off to become a commercial entity, and I continued working with it to this day. I graduated from McGill 7 years ago. So it really determined my career. It gave me an opportunity that determined my career path. And I joined the company from the point it was born, so its stages and all the fears and all the stresses. Did I know? Actually, when I was doing the short program, I was building my resume to do masters and PhD. That was my. I really wanted to go into research, but somehow the initiation of this company plucked me out of the research field into implementing that research in the commercial field. So I find it personally not only helpful for you to get good research experience. Potentially it might lead you into, if you're interested more in the industry than in research, it could also give you contacts with the industry. Now, when we hire people at MY01, for example, we do look at their research experience. I think that's you joined us. That was one of the reasons. We do those tell you something about the student. Of course, also industrial and experience also counts, and we do consider it. But maybe try it for a summer, see if it's good or not, and then go. If you don't like research, you don't think it's your thing, you want a more fast-paced place, do an internship in the summer and go with it. I think you have maybe 4 summers or maybe 3 summers in your studies. You do have time to experience things. And there are many things to experience. There is the work for research when you do the short program. Sometimes it's work for gaining industrial experience. You join a big name that has a lot of fun and new projects, and you want to gain industry experience from them. And maybe for money, you join a big company that pays well. You don't really care, which is also valid. So try them and see which one you like.
And I think it's kind of like the advice that I've been hearing, and I've been trying to share with my classmates also, is just trying things, because obviously it's a 4-year undergrad, which is a long time, but you have only 3 summers to really get hands-on experience. A lot of people could handle doing extracurricular research, but that causes a lot of stress when you're dealing with school and you want to get your grades at a certain level. Trying things in the summer, really just exploring opportunities. I think that's something that students in any department, any faculty can really benefit from, because you only have a limited time of being at school. You can have access to all these resources, right? Once you graduate, you might not be able to do the short project anymore, or something like that, or just joining design teams on campus. If you think that you don't have enough research experience to join a lab, there's a lot of precursors that you can work on.
I can add something to that as well. I think also there's this thing where people don't realize that it's also, you don't just need to use the SURE program, for example. Sometimes it's very selective. You could also reach out to professors directly in your classes or your TAs that are part of labs.
Sure.
Also, my first summer, I didn't think I'd get SURE, so I actually reached out to the math department, and I spoke to a few profs there, and I actually applied to an intern with them outside of the program. I ended up not taking it because I did the SURE program, because I was surprised that I would get it. I think it was also because of COVID, a lot of labs canceled their SURE program, so they might have increased the number of people. But essentially, sometimes it's hard to get these programs, and people stress a lot about, it's only SURE I can get, but you can also reach out to profs directly, and sometimes they don't even care about your GPA, because there's a requirement for SURE for their GPA, but there isn't for other things.
That's a good point.
And another thing I would say is, it's not just about the work that you're doing in the SURE program, you're also getting access to grad students that went through the same thing as you did, and you can get advice and insight about their career path, and it's always about learning from other people as well. So that is also something that you benefit from if you do some research, or if you go into do internships as well, because you get experience with.
That's a very good point. I think I want to echo that. I think just for example, for last summer, I just emailed professors that I saw some work that they were doing that was interesting. It was in like medical imaging, so I was looking at that a little bit. So I just emailed the profs, and some of them didn't get back to me. Some of them got back to me. So it's just a matter of trying your best to reach out. So I think that's really good advice to
You
students.
didn't do a short program.
No, I didn't do a short program. I emailed the professor, met with her. She discussed her work, and she said she wanted to give opportunities to students to learn. No, it's profs want students to get involved in their work. It's not sometimes, I guess, people think about, oh, why would a prof want to work with me? I don't have any experience. But sometimes the profs want to give you that experience because they want people to be interested in their work. They want people to get access to these, because maybe they know less how it feels, but they know how their grad students felt a few years ago. Some of them are a little bit older. But yeah, I just think being open and being like motivated to like send emails, go to events. A lot of universities have like events where you can talk to profs and network with them and just meet with them to see what opportunities are, because opportunities are there. It's a matter of you finding them, right? So maybe that's a little
Even
bit.
in classes, you could speak to your profs if you want to. It's like I think you make connections with profs. If you stand out in classes, like you ask them questions and stuff, they're more willing to, like, they'll remember you and be like, oh right, you were in my class and you were very interested in this. So like it's about, I guess, networking as well in your classes and stuff like that.
Yeah, profs like when you ask them questions about their work, so they can talk to you about for hours if you want to. You just ask them questions and they can give you some insight and hopefully get you some experience in the summer.
Yeah, I think especially for like the young students, don't be discouraged if you get like rejection from a professor or from a company. Like just keep going. Like especially if you're very fresh in your first or second year, you should never be discouraged. But like sometimes we get these amazing resumes, like student has done a great deal of work, they have a lot of experience, they have a good GPA, but like we're not doing anything that relates to your experience, so it just reject it. It doesn't say anything about you. It just says that there's no alignment between what we need now and what you offered. Sometimes I see a resume and I'm like, I wish we had this like a year ago, but now we can't. Sometimes you do have a very good resume, but someone who by fortune was born 2 years ahead of you has now 2 years more experience.
True.
So you will get, in the initial years, you might get rejected quite a bunch. Don't just keep going. Keep asking professors, companies. Don't let it get into you, or don't think that you're not good for doing anything. Getting stuck in that loop where you think I'm not good for internships or for sure is a very bad thing. I think you apply, you'll get rejected. Learn, apply again and again and again. I think for the advantage of this undergraduate research is that you have the professor in front of you, like you said. Maybe you're taking a class with him.
Yeah.
So you can go and like speak to the professor, and you have the entire building full of professors in front of you.
Yeah.
But I actually did something similar to what you did. I would knock on their doors.
Oh, I did not.
In my first year.
Yeah, wow.
So a lot of them would be like, okay, what did you do? And by that time I did basic math, basic physics. They're like, no. And like, then I kept knocking until one of them said yes. And
So it's just a matter of really just like reaching out and doing as much as you can.
The more things you do, the more chances.
Exactly.
It's like,
so you can write 100 emails and you'll get one of them, right? But the 1% will be much less significant if you send 5.
yeah.
Right. So, I think that's great advice for students, and it's good to hear it coming from you guys who have now have positions, right? So you guys were able to make those contacts and connections, and that helped. I mean, I guess for you it was a little different, but those contacts that you researched with and kind of stood out on your CV when you applied to either MY01 for an internship or to your current position. So I guess we can jump into maybe to talk about more about what MY01 does. I think something that would be interesting for people to learn about. So I mean, I already know what you guys do, and maybe you'd be a better person to talk about like what ACS is and what the device works on and sensors. And I'll ask Rachel to talk about a bit about what she's doing now, though it's really fresh. So if you can talk about a bit about MY01. You spoke about the path, maybe more about the technology and what you guys are really working on.
Yeah. So maybe I will start by explaining what ACS is.
Yeah, please start.
So ACS stands for Acute Compartment Syndrome. When you have like a high energy trauma or high energy hit to one of your extremities or your limbs, basically when you break a bone, the muscle, you can think about it as a balloon. It has a fascia around it, and that fascia doesn't expand that much. Mm-hmm. So it's a balloon, but a very tight balloon, I would say. Now, when you have a trauma to the limb, when you break a limb, that muscle might start swelling and has a fluid buildup inside it. The buildup of fluid inside the muscle might reach a point where the pressure inside the muscle beats the pressure of the blood flowing into the muscle. Mm-hmm. So the blood is delivered to the muscle through vessels. Mm-hmm. The muscle pressure might be high enough that it prevents blood from flowing into the muscle. So when that happens, the muscle is not getting nutrients, it's not getting oxygen, it's not getting rid of CO2, so it starts dying. Now what happens when the muscle tissue starts dying? More fluids accumulate. So with more fluids, you get even more pressure. Yeah. And the more pressure you get, the less blood gets into the muscle. So you get into this positive feedback loop that ends up with the necrosis of the muscle. Yes. So it could be the muscle, nerves also might die or get damaged. After all, the muscle will die. And when tissue that big in your limbs die, it's not a good thing. In cases they do have to do an amputation. So this is ACS, Acute Compartment Syndrome. Basically the muscle death due to increased pressure inside the muscle. Now what MY01 does is, as you know, we started from a sensors lab. Mm-hmm. And one of the sensors we know about is pressure sensors. Yeah. So we designed a pressure sensor, a single-use, ready-to-deploy pressure sensor that you can implant it invasively inside the muscle, and it measures the pressure directly inside the muscle. The doctor takes that pressure, compares it to the blood pressure, and also looks at other clinical signs. And the aim of our pressure values is to aid the doctor in making a diagnosis. Is an acute compartment syndrome going to happen or not? Okay. Now, that field of measuring pressure inside the muscle, we're not the only device that is there, but the devices that are in the field, I'm not gonna diss the competitors, but there has been much development or attention to the clinical cases and the design of these devices. Okay. So what we try to do in summary is to have we have the implantable sensor. We implant it to measure pressure in the muscle. Our device communicates to a mobile app via Bluetooth, and through the mobile app, you can actually, other team members in the medical or the healthcare team can also take a look at the data and see how the pressure is behaving inside the muscle. So we're basically trying to bring like sort of the 21st century into this case, into acute compartment syndrome. The idea, we also, one of our founders is a professor of surgery at McGill, Dr. Ed Harvey. Yes. So basically, ACS specifically, if you go into the medical field, there's a lot of subjective opinions about it. And he's a man who likes objective data. And one of the things that used to anger him is that around this case, he was never able to get like objective data on the pressure with the tools he had at home. At the time, you contacted FAMC, and then they started this collaboration, which ended up becoming the Next Sense and then the MY01 company. So every once in a while, we joke with him. We tell him like, "What's angering you these days?"
Give that idea. Yeah.
But this is in summary what we try to do. We help the doctor in having objective data of the pressure inside the muscle, so they can make a call on whether or not this is an acute compartment syndrome case or not. And it's a severe case, like you're gonna amputate a limb.
So very serious.
It's not something to be taken lightly.
Mm-hmm. No, for sure. I mean, I think I've seen like some presentations about the device, and I mean, you'll talk more about it during the conference as well. But yeah, Rachel, if you can also maybe you don't have to go into such depth as Nizar did, because obviously you just started your role recently, like this week, right?
Yeah, this is my first week.
Yeah, maybe just you can talk about where you're working and where you're working on, and as well as, and then we'll talk about really electrical engineering in the biomedical space.
Yeah.
So go ahead.
Yes. I started my role as a product engineer at Rogue Research, which has been a company that's been working in neuroscience, working on building equipment for neuroscientists around the world for about 20 years now. It essentially, their flagship product is BrainSight, it's called, and you can think of it as a GPS for the brain. So in general, in the neuroengineering field, there has been a big rise in TMS. This is transcranial magnetic stimulation. And that is, you are using a magnet, so a coil that actually induces current between two neurons, for example, or within an area of a brain that is not having enough stimulation, or there's some medical condition that's preventing the flow of information from neuron to neuron. So this field has been very big. I know that in bioengineering, in your program, you have spoken about this in your classes.
Yeah. So we've spoken when it comes to like a neurophysiology. There are some professors at McGill Bioengineering, Professor Mitzis, who works on MRI, EEG data, and then we did talk about like deep brain stimulation, which is DBS, which is I think like the overarching method that you're talking about.
Yes. So essentially, what Rogue Research does is, in general, what most researchers would do is just have a coil. It's usually like this size. And they just like find, in this general area, this is where I should be stimulating. Mm-hmm. And it's very imprecise because you are having this huge device and you have to place it in like these neurons that you're trying to stimulate. The region is like millimeter by 1 millimeter by 1 millimeter, usually smaller than that. Yeah. So it's harder to be very precise. So what BrainSight and the product that Rogue Research provides is actually you go for an MRI, for example, it loads the data from an MRI that you did, and then it maps. They have a 3D camera that actually maps the images to the brain that you're using, and you're using a coordinate space that is known around the world. So then you could be very precise in the location that you're supposed to stimulate. And then what they do is they actually provide separate equipment that actually does stimulation, or you could use your own stimulator, and you are able to, it shows you what angle you have to put it, because also the brain is not a box. It has curves and everything, so it provides a software that actually lets you it helps the researcher actually find where to stimulate, and it's precise up to 1 millimeter, even less sometimes. And so that presents a lot of challenges because you have to have a camera that's your body moves, right? So you have to also be able to adjust for that as well. So
very cool.
So that's what Rogue Research does.
I
just started, but it's
very
cool.
Really cool.
Very cool.
You see, like the thing about those medical devices, like they are so multidisciplinary. Yeah. Like you have that system. I'm sure, like you do need mechanical, electrical, software engineers.
Everything.
Our device like is about this big. It's an implantable, so it's invasive, and we do have like 4 engineering teams working on it. Firmware, mechanical team, electrical team, and we do have like a sensor team as well. So basically, something that small, you do need just the engineering work. Forget about regulatory, forget about sales and all these things. You need 4 or 5 teams collaborating to make it happen.
It's true. Yeah. Also, like on my interview, they were asking like for our product, there's like they were asking me like if you were to rank mechanical, electrical, and software, what would be the strength that you have in each? Because they do require you to understand all of it, especially like in my position, it's product engineering, so you're supposed to be able to manage the electrical, the software, the mechanical, and they also have an app, and there's other things. So it just becomes like a big project, but that's what's cool about it too, because you are supposed to be able to combine all of this together and make sure that there's no conflict between all these different subsystems of your products.
That's a good point. I think that's really where like biomedical engineering like stands out from the other fields. I mean, it encompasses all the different kinds of engineering, right? So, like you mentioned, like your sensor has obviously mechanical components, electrical components, software components, and your machine has everything too.
Yeah.
So, and this is kind of what I think people in the undergraduate biomedical engineering maybe sometimes are overwhelmed with, but also they really get to learn tools from a lot of different fields, and that really helps them like be able to work on multiple projects, and even communication with like mechanical teams, communicate with electrical teams. They really can like speak the same language. I think that's really what like biomedical engineering can at least like propel for students in the field.
It also helps you, like if you like you're going into some program and you don't know if you want to do mechanical and electrical or whatever program you can, but you do like for example medical stuff, you can go into bioengineering. But I think also you have to, because it's still a 4-year program, you have like a lot of different, you get a bit of everything, but it's also up to the student to find what they really like and then really go deep with projects or
that's true.
Different things like this as well.
It's a good point.
That's a very important point for biomedical engineering students. Is it's like if you want to work on the technical side of medical device development, not in project management, I think having diversified knowledge is helpful. But if you want to work on the technical side, you want to actually do engineering, like hardcore engineering work, do try to focus on something, either electrical or mechanical or software.
Especially at the beginning, and after you get some experience with it, you can also you can kind of become more. You have to have some like technical, I guess, knowledge in all of them. And I know people who do in bioengineering and other things, but it's a lot of it has to do with your projects that you're doing, the research things.
And it's something like at least like I've struggled with. I think in my undergrad is like there are so many I think like cool things that you can do in bioengineering, biomedical engineering. It's a matter of like do I want to do like CADing for prosthetics, which is more mechanical, or do I want to do like signal processing for medical imaging? But you do have to pick. Which is like I haven't chosen yet, which is kind of stressing me out a little bit. But it is something that I think is good advice for students to like, even though there are so many opportunities, just to kind of like we said, try things out to really narrow down what you want to work on. And I think that's kind of what we spoke about actually in our last episode with the design team, is like learn and try new things, and then you'll be able to like, I find for me at least it's more of canceling things I don't like more than choosing what I like, and that way you get an easier a decision, right? You can say, okay, I don't like this, so then I have to consider that field, right? So I think it's really a matter of trying things out and really narrowing down what you want to work on. So I think maybe now we can talk about like what, like in general, does like electrical engineering. I know we talked about sensors, and you're doing medical imaging somewhat kind of thing. So what are some other areas that you guys can think of, or you guys know that like electrical engineering plays a big role in medical device development or in certain therapies in biomedical engineering?
Like everything nowadays, luckily requires a circuit, so that keeps us employed. But if you think about it, like in the medical industry, unless it's purely like mechanical device, such as like a catheter that cuts something, you do typically need an electrical engineer. So when it comes to what electrical engineers need to do, or is there a place for them in the medical device industry, 300% they're needed. I think electrical engineers have an easy time also going into software and learning software. We do have our embedded programming team, most of them are actually electrical engineers, which gives them a specific strength because they understand the hardware and they're also good at programming. When as an electrical engineer, I'm biased because I'm an electrical engineer. I liked it. I like doing that. In the medical device industry, there's circuit design. Basically, there is a lot of regulation around your circuits and how they need to behave, and about your device, overall device, electrical regulation. There is a whole standard IEC 6061-1 just for electrical medical equipment. So basically, there is a lot of work to be done inside a medical device as an electrical engineer. There's circuit design, sensor integration is also important. Software is everywhere, embedded app, wherever there's a software item needed. If you enjoy hardcore electrical engineering things, that narrows it a little bit, but there is still also a space for it. I'm thinking just about our company, which is was founded about 7 years ago, something like that, 8 years ago, and we do have a lot, and we have the MY01 device. There's circuit design inside it, sensor design, programming. The systems that we use also to produce the device and manufacture the device, those also need an electrical engineer. So as an electrical engineer, there is a role. I do have an advice for electrical engineers as well, is don't just limit. If you want to go into the medical industry, it's good to delve a little bit into another field, mechanical engineering. Learn a little bit about mechanical engineering. It does help you. It helps you in many places, actually. Delve a little bit, maybe into software instead, but choose something secondary or cool, your own personal minor, and do learn about it. It helps you a lot. I've never seen. That's also one thing I've never seen, at least in our company where I worked, and I'm sure it's the same case in many other development companies. I've rarely seen an electrical engineer who's just doing circuits and calculating circuits, and you always have to do something else, a little bit mechanical on the side. When you were working with us, a good chunk of your work was actually mechanical testing and simulations. Other members who joined us, they are electrical engineers, and they do work on actual hardcore electrical engineering problems, but they do have to their background, for example, in software and data processing, help them significantly. Sometimes your background in physics helps you a lot. Maybe delve a little bit into physics. I find physics in general, if you're an engineer who's also strong in physics, I find that to be a very good recipe. I don't know, but I feel that physics gives you a very deep a very good framework to think about problems. And I see it. We do have few physicists in the company who do. Some of them, I don't know if you remember, I'm not going to mention names, but he basically used to detect, cosmic radiation and stuff that. We don't do that.
You guys don't do cosmic radiation.
We don't do that, but when he joined us, he's been very critical and very helpful in his work. The skill sets he used there, he brought them here, and somehow detecting cosmic radiation and designing devices under regulatory standards, somehow there is a skill set that applies to both. So yeah, going to your about electrical engineers, there's a place for you in the medical device industry, for sure. Learn something else as well on the side.
Yeah, that's good advice, and I think like there's so many different I think applications in the medical field now that involve electrical, like you mentioned. Everything basically does. Like surgical robotics, for example, is a field that's rapidly growing, and a lot of big companies are working on facilitating surgeries, whether that's with optics or with robotics too.
Yeah.
And like you mentioned, it's kind of similar.
Yeah.
So I guess, Richard, you can talk about maybe some different fields in the medical space that do deal with electrical, either hardware design or electrical engineering in general.
Yeah, I think I also want to reiterate what Nizar said about the fact that you need to have something else. Because I think especially if you're, let's say, designing some circuit, you also need to produce it, right?
Yeah.
And especially for the medical device field, you also need to make sure that it's usable by a doctor and it's comfortable for the patient. And that brings a whole area of ergonomics to your device, right? And that is mostly mechanical. Yes, there might be some electrical stuff if you think about it, but it's also mechanical stuff because you need to make sure that it's like any device is comfortable to wear. And especially, for example, for what I'm working on also, there's going to be stuff related to how are you going to image it and make sure that the patient is wearing the right gear and all these other things, and they have to be comfortable for you as well. So there's a lot of things related to that. And for your question, you asked about, can you repeat the question?
It's mostly just obviously the medical field it's huge. I mean, there's diagnostics, imaging, surgeries, and I guess what are some interesting fields that maybe are not what you're working in now, where you're working that involve electrical engineering? So I mean, because you worked on breast cancer.
So
there's so many things that electrical engineering is involved in, right?
Yeah. So I'll mention my first research was we were using optics to run a PCR test. So we were sending an LED or some other light. It was actually not. It was some light that would send through a DNA sample, and then it would produce a signal, and you could detect if there was some sort of bacteria in there or not. So that obviously has a lot of electrical stuff. Yeah. So one area is photonics that we didn't really mention that much yet, and photonics has a lot of biomedical applications as well. In terms of other fields, any sort of equipment, I guess
maybe it's a tough
question because we already mentioned a lot. Yeah, it's even what you mentioned was catheters that are mostly mechanical, but you need to manufacture them, right?
Yeah.
So that you need to create machines to actually manufacture things and all these other things, and that's also electrical as well, So right now any field requires electrical engineering to.
I think it's so wide to say, this skill set will really be really helpful, or that skill set. From my limited experience, my limited medium, the medical industry is huge. I work at MY01. Embedded programming was a great asset. Mechanical knowledge was a great asset. Software knowledge was also a great asset. Just knowing, being very good at a certain programming language, and or math, data processing. I would say data processing was a pretty helpful skill. And I'm sure if you picked a fourth thing that I didn't mention, and you became really good at it while you are an electrical engineer, you would probably find a place where you can apply it.
Yeah. So I guess maybe if we can go more specifically to what your guys' day-to-days are, working in the industry. What does your day-to-day look like? I know it's different every day, and maybe you won't be able to give a great description, but in terms of how much time are you really spending designing or documentation or meetings? What does your day-to-day really look like on a scale? Because I think most students don't really know unless they have done internships or things like that. I mean, I think it's pretty obvious what researchers do. I think it's a lot of experiments and a lot of data processing. But as an engineer in industry, you're a research and development manager, and you're working in product. So, what does your day-to-day really look like in terms of the split?
Maybe I'll try to shed light on the day-to-day of an intern. and then on the day-to-day of
that would be useful too.
Because I think those would be more useful to interns.
Mm-hmm.
So I would speak about MY01 specifically.
Sure.
Basically, there is no hierarchy or segregation of like an intern / an engineer.
Mm-hmm.
When you join, you have a skill set, you join the team and you start working. You know everything about what you need to be working on.
Okay.
You're typically handed a general responsibility. So there is no, sit down and record these values on Excel for like 3 days. There is some of that. We do that. Even the engineers get some of that. But in general, you start, I would say, we typically do about 8 months internships. We prefer them to 4 months. Because typically the first 2 months, you're like just learning. You're understanding what the hell are they talking about. After you get through these 2-3 months, then you become like an active participant in a project. So whatever project that is being worked on with your team, you're following up with them, you're working with them, you're joining their morning meeting about the project if they have one, and then you're learning what your tasks for the week or for the day are, and you just go through it. In the last 4 months, we do our best as circumstances allow, because it's not always it's not always rainbows. In the last 4 months, we do try to put a specific effort into giving the intern their own project, something they work on, that they deliver, and they say, okay, this is my thing that I delivered. We have like pieces of equipment that we still name them after the intern who made them, or like we do. And also when you leave, you remember that I finished this thing, I did this thing.
Contributed something to the project.
It's a good. So in that point, I would say it's more responsibility, more you're like dealing with multiple aspects of your little project at the same time. You do it, and the more you stay with us, a lot of interns do 8 months, then they come another time. Actually, we do have a lot of interns who come back. So the more you advance, then the more freedom you have and the more responsibility you get. So there is that you do get some tasks. Every one of us do get some tasks where they sit and do record data from something for 4 hours. Yes, someone has to do it, but we try our best so you don't get much of that. You get a lot of what you need to learn. We do think about what can benefit your resume after you whether you continue to work with us after you graduate, or if you want to. Actually, a lot of the people we hired are started as interns at MY01.
Okay.
We do try, even if you want to go and work at another company, or you tell us what's your preference in general, we do try to consider that, and we do try to enrich your resume so you go and you succeed and you become a good medical device engineer. So that's for the intern. The day-to-day, I was not an intern at MY01, so that's my subjective account.
You can maybe talk
about it. For myself, it varies. I've been working with MY01 for 7 years. So in the beginning, I think we just worked on whatever that was needed, because it was a very small company. We needed to get through our approvals and enable the selling of our device. So that was a very, I won't say day to day, maybe night to night. We used to work a lot. Occasionally, we might sleep in the office, but
that's the beauty of it.
That's the beauty of it. And it was a lot more technical work.
Okay.
I would say after our product was approved and we were able to sell it, the focus was more on how to simplify and improve our production cycle.
Okay.
So we make it better, more controlled, less easier to make product. That was a good chunk of my time. And then recently, I do have a lot of meetings, more than I like, so I'm trying to cut on them. I cut on them as much as I want, as much as I can. But I did do something. I became a manager a while ago. Recently, I've tried to revert back into more of a technical role.
Okay.
So I'm trying to get more involved on the technical things and going back into technical work. So I would say this is also something maybe that might be beneficial to other managers who might get consumed in, project timelines and personnel issues and growth maps and all of this. The best way I think you can help your team is probably delving deeper on the technical challenge with them.
Interesting.
It's somewhat counterintuitive sometimes, but actually just delving with them on the technical side helps. I found it to help more. It also, as a manager, it brings you closer to what's going on, much closer.
Yeah.
As much as you like to think that you know what's going on, you actually don't know unless you're your hands are dirty and you're on the ground.
Yeah.
Of course, you can't let that also. You do need to reserve some time to do the strategic thinking. What are we doing for the next 6 months?
Yeah.
What are we doing for the next year or 2 years? Outside of that, and this, I think if you do the strategic thinking, if you do involve yourself on the technical aspects heavily, the other things, the project timelines and the personnel matters and, growth maps and all of that sort of resolve themselves.
They'll fall into place if you spend more time working on the technical design with the team.
Yes.
Yeah. And I think that kind of bridges the two together. I think sometimes, I guess maybe I'll bring myself as an example. I can't seem to find a good place where I can combine both managerial kind of role and technical role.
Yeah.
Because it's really often just split. You have the engineers who work on the design, and then you have the managers who are working on, like you said, project timelines, growth strategies, which I also find interesting. But I'm constantly looking for ways to kind of merge the two, and it's good that there are some places for that, because a lot of engineers either just go away and go into consulting completely, and then they detach themselves completely from the technology, right? But I think some of them want to have a little bit of both, and it's really motivating to hear that there are some solutions for that. So maybe, Rachel, before you go into what you're doing now in your day-to-day, maybe you could talk about your internships and at least at MY01, like you said, there's no segregation between intern or engineer. So maybe you can talk about what your day-to-day was when you were an intern at MY01, and then you can talk about what your week was in the past week. So what your day-to-day is now.
Yeah. I can say one thing that is different from when I worked at MY01, from what I've heard from other companies, is that I had actual design work to do. I had actual responsibilities. Well, when I spoke to other people who did some internships at bigger companies like Bombardier and things like this, or other companies as well, because there's such a big team, a lot of times it was the same thing over and over again, measuring the voltage all summer or something like this. And I think one side of it is because I had an 8-month internship and you get the chance to actually learn, but also I think it's when it's a smaller company, you do have a lot more responsibility, and that was really helpful. Honestly, I love my experience, and it's also, I learned so much, and especially when I went into my interview for my job right now, a lot of things that I have done, it is very translatable, and they were surprised that I knew about some standards that I worked on, specific things like that, because now it's my job right now. What I'm working on is, so I'm working on the product life cycle. So I'm assigned a product, and I'm going to be managing the entire site from the regulatory side, not exactly all of the regulatory side, but I'll be managing some of that. Also be working on the risk assessment side of it. But I'm also going to be working from the conception, so like why you're doing this product, to developing the product, to producing all the documentation for production for that product. And then I'm going to be planning the testing. So a lot of it is project management, but it's from the perspective of the product itself. So it is still pretty technical, I guess, but it's less, instead of actually designing all the PCBs and other things like that, I'm going to be making sure that PCB is compatible with a different PCB from a different sub-team that is working on it. So things like that.
Parts.
Yeah, a lot of it is like that, and also making sure that it is compliant to other standards that you're working on and things like that. So it's pretty challenging. It's a lot of reading. So I've been reading a lot this past week about different things, and it's always difficult to switch from one way of doing things to another one, because there's different ways of doing stuff. So that's the challenge for the next few weeks, but I'm looking forward to the challenge.
I'm very confident that you'll be able to adjust well. I mean, I think that's kind of an adjustment you have to make when you enter university too. The dynamic is different for students. You know one's holding your hand anymore. You have to really take things on your own, and there's a similar transition when you leave university and either you're going to grad school or when you're going to the industry. So I think that's a great place to end it off. So again, I want to thank both Rachel and Nizar for joining us today and talking about MY01 Rogue Research, your experience at McGill and undergrad, also. I guess just like what students can look forward to in the industry once they graduate. So all the information for MY01 will be linked if you want to look at different internship opportunities for the summer or during the year, as well as their product. It will be linked in the description. And for Rogue Research also, in terms of what they're working on, the product. Thanks again for listening, and thank you to both of you for joining me today.
Thank you.